Hello everyone, myself Saurav, and today's topic is definite integral as an area. If I ask you to find the area of a triangle, rectangle or circle, you know the formula, right? But if I ask you to find the area of a leaf or let us assume a curvy land next to a river, which shape is like that? Can you find it? No, right? So nature does not always follow the straight line or a perfect square. So we will get many shapes in the nature which are irregular or curvy structures. So how we can find those type of find the area of those type of shape? In this class, we will learn to find the area of a shape which is under a curve by definite integral. So let's take a function f of x which is continuous and monotonic increasing in A to B. Okay. So let's draw the graph. So x, y dash, x dash. So take this monotonic increasing graph. Let's say this is x equals to A. This x equals to B. Now the problem is we have to find this area under this curve y equals to f of x, right? So let's see what is the length of this line segment AB. So length will be B minus A, right? B minus A, right? So now to find the area, let's divide the AB line segment into n equal parts, equal length of parts. So let's say, let's divide the line segment into n equal parts. So okay. This. Okay. So what will be the length of each part? So let's assume this is H and we'll get the value of H. This is total length. By how many parts we have divided it? N parts, right? So H equals to B minus A by N. So we will we get the value of H. So now we have N parts. So what will be the total area of the required area? This will be the sum of all N parts, area of all N parts. So now make this each part, make those part into rectangle, in rectangles. So this is all the rectangles, but each rectangle is, the area of each rectangle is lesser than the actual area of the part, right? So let's suppose the actual area of actual area, okay, S1, total area of, so we called those type of rectangle inner rectangle, and okay. So now we can divide, we can make also another type of rectangle, this one, this one, this one, this one, this one, right? So see here we are getting extra area, okay? So we called this this type of rectangle is outer rectangle, okay? So in case of outer rectangle we are taking extra area. So let's say this is S2, total area of outer rectangle, okay? So now think what will be the value of S1? So S1, we will find S1. So what will be the value of S1? Total area of inner rectangles, total area of outer rectangles, okay? So what will be the total area? So take each each rectangle. So take the first inner rectangle. What will be the length? Breadth. What will be the breadth of this rectangle? H. So every rectangle is of breadth h, but height are changing here. So height will be here. The first inner rectangle's length is this. So the value of this will be f of a, right? So the length of next rectangle will be f of a plus h. Okay. This is a and this is a plus h, and the next point is a plus 2h. Okay. So in this way, the last point is the point b equals to a plus nh. Right? We are getting from this b equals to a plus nh. That means the last point is a plus nh. Okay. So in this way, so this will be okay. The last rectangle's length will be this, right? Not this. So what will be the value of this? H into f of a plus this is a plus nh. So this point is a plus n minus h. Okay. So if we simplify this, so this is r equals to 0 to n minus 1 f of a plus rh. Got it? So now find S2. So what will be the value of S2? So we will get so S2 is total area of outer rectangles. So outer rectangle's length is f of, now this is the length. So we are taking this point. So this point is f of a plus h. Okay. So in this way, the next rectangle's length will be a plus 2h. In this way, the last rectangle's length will be f this. So this point is f of b. So it is f of a plus nh. So if we write here an extra f of a, so this will be, and here term we will get this. Okay. Sorry, it's n minus 1 h. Okay. Right. And after that we'll getting this one. We take extra term here, so we have to minus this h f of a. So if we simplify this, we will get r equals to 0 to n minus 1, and here f of a plus rh. Okay, and now those two terms. Okay, so see here, this is S1, right? And we are getting the extra term this. So now think about if we increase the number of rectangles, like we are dividing the AB line segment into many in a large numbers of parts. So if we increase the value of n here, so we are getting the smaller h. So that means if we take n tends to infinity, like so what we will get? We get h tends to 0. So that means if we take infinite numbers of parts, so we will get each rectangle's breadth will be tends to 0. So then what will be the value of S1 and S2? Let's find. So when h tends to 0, so limit h tends to 0, S1 equals to what we will get? So what will be the value of S1? So it will be this. So f of a plus rh, right? So r equals to 0 to n minus 1. So what is this term? This is actually the definition of definite integral, right? So we can write this form as the definite integral of f of x, where the lower limit is a and the upper limit is b. Okay, got it? So now find the S2. S2. So what we will get? We are getting this term also. We have to write this, na? So this is a nh minus h of a, right? Now think this is actually a plus nh means this is f of b. So f of b this point and f of a this point. So those points are finite. So since h tends to 0, that means the whole part will be 0. So what will be the actual value, actual limiting value of h2 is this, right? So this is f of a plus r h. So now this is the definition of the definite integral of this form. And this is the same one with the S1, right? So what we can write here, so we get S1 equals to S2 equals to integration a to b f of x dx, right? So now think S1 is a less than S. S is the actual area which we have to find. This is lesser than S because we are taking the inner circle and we are leaving these portions for each in each part. When we are taking the inner circle, we are leaving this area, right? So clearly S is less than S2 because when we calculate the outer rectangle, so we are taking the extra areas, right? So that's why S2 is greater than S. Okay, so we getting this relation. Also, the another relation is this. So this equal to this and this equals to this. So here we have to take the limit. We have to write the limit, right? So from this we can write this. This equals to, right? From this we get this equals to a to b f of x dx, right? So we find the area under the curve of y equals to f of x if f is continuous and monotonically increasing in this interval. Okay, so think about if the function becomes monotonically decreasing, then what will happen? Let's see. Take a monotonically decreasing function. So similarly, we can prove the area of this, the area under the curve, when it continues and monotonically decreasing, we easily can prove the area will be this. How? Let's see. We will divide the area. Okay. Let's draw the graph properly. So let's take a monotonically decreasing function here. So this is a monotonically decreasing function and divided it into n parts. So okay, right. So now draw the inner rectangles and outer rectangles. This, okay. So similarly, we can calculate and prove that the area will be this. So now let's take an example. Let's take a problem and try to understand our formula is working or not. So let's take this example. Okay. So there is a problem. We have given 4y minus 5x equals to 0 and x-axis and x equals to 4. So we have to find the area bounded by those lines. Okay. So let's draw the lines first. So here we have the x equals to 4 line. This is x equals to 4. Okay. And what will be the graph of this line? So it's like this. This will passes through the origin, right? Now the required area is this. So what is the line equation? Is this and this is y equals to 0, right? So we have to find this area. So let's try. Area equals to. So what was the formula? The formula was like that: a to b f of x dx, right? So f of x means y, right? So what is the value of y here? So this is the function here. So what will be the value of y? 5 by 4x, right? So and what will be the a and b here? So a here is 0 and here 4, right? So upper limit and lower limits are 0 and 4. Sorry, 4 and 0. And y equals to 5 by 4 into x into dx. Let's integrate it. So what will be the value? 5 by 4 integration of x dx 0 to 4. So what will be the value? The value is it's x squared by 2 0 to 4. So this is 16 minus 0. So the value is 10 square meter, not meter, not square unit. So this is the answer, right? 10 square unit. Now see here, this is a triangle. So we are getting the area is 10 square unit. So now find the area using our triangle formula. So this is a right angle triangle. So what will be the area? Half into letter A and B. So base and height. Height is A. So clearly this length OA equals to 4 and AB, length of AB. So this point, the B point, the coordinate of B point is 4. X side is 4 and Y coordinate is will be. We are getting from this, so it will be 5, right? So 4 comma 5, right? So AB, length of AB will be 5. So this is 10 squaring it. Okay. So we are getting the same answer from if we calculate this using definite integration, definite integral, and if we calculate using the formula, right? So let's think about a graph which is not increasing, monotonically increasing or decreasing. So let's take y equals to sin x. So what will be the graph of sin x? So if we draw the graph will be like this. So this is 0, x equals to 0, and this is pi, 2 pi, right? And it's 3 pi, and this point is x equals to pi by 2. Okay? So if we notice here, this curve is sometimes monotonically increasing, sometimes it's monotonically decreasing. So we prove that if the function is continuous and monotonic, like it's monotonic increasing or decreasing, we can find the area under the curve using the definite integral. If we take a continuous function which can be monotonically increasing sometimes or monotonically decreasing in some interval, then how we can calculate? Let's think if we take this portion 0 to pi, then so this is this part. So the function is monotonically increasing in this part 0 to pi by 2 and monotonically decreasing in pi by 2 to pi. So in this type of function which is continuous, so we can divide into two parts here. In first part is this, and another part is this, and then using the definite integral, we can find the area and sum those two area. So in this way, we can find any area under a continuous curve, right? Dividing the area into monotonically increasing part and the decreasing part. So if we take this type of function, what will happen? So this will be f of x dx plus pi by 2 pi f of x dx. So here we can write 0 to pi dx. So in general case, if the function is just continuous, we can write the area of the area under this curve equals to integration into b f of x, right? So let's find the area of this area. Okay. So let's find 0 to first we will calculate this portion and then this portion. Okay. So 0 to pi. So it's a1 and let's say this is a2. So this is sin x dx. So what we will get? So integration of sin x will be minus cos x. So it's pi. So then we will get minus 1 minus 1. Okay. So that will be plus 2, right? Okay. So value of a1 equals to plus 2. Now find the value of a2. So it's 2, right? What will be the value here? Cos x. It's 2 pi, 2 pi, and the value will be cos 2 pi 1 plus 1, and cos 2 pi, sorry, cos pi is minus 1, and so minus minus plus, it's minus 2. So think here, a1 value, this area is 2, the value of this area is 2, and the value of this area is minus 2. How we can get the value of an area in minus? Here we are getting minus value because here the f of x, the value of f of x in this region is minus, right? Negative. And in this region we get positive. So we have to keep in mind that when we calculate the area under a curve, the function should be always in same sign. Either it's positive or negative, right? So we have to keep in mind the function should be same sign in the interval. Either it's positive or negative. So in this, what happens if we take an interval like this, where in this range, which is f of x is positive, and in this range the f of x is negative. If the in the total area from 0 to pi. So in this case, say here f of x sometimes positive and sometimes negative. So we have in those cases we have to divide into parts where each part should be the same sign of the function, either it's positive or negative. If the function is negative in the interval, then we will write the function as it is. Okay. In this range, the function is positive, so we will write the function as it is. But when the function value is negative, we will add an extra negative sign before the integration. So this will be right. So we add this negative sign before the integration because the function value itself negative. So the area we will get negative, right? So that's why we write this extra negative sign. So we previously calculated this a1 is 2 and the value of this a2 is minus 2. So now we get the total value of this a and a2 equals to 4 square unit, right? So let's solve another problem. So take, so this is a circle. So we have to find just the area of the circle which in the first quadrant. So we have to find this area. So now, how we can find? So this is the radius is 4. So that means this point is x equals to 4 and this is x equals to 0, right? So area will be integration 0 to 4 y dx. So now let's find the value of y. So it's 16 minus x square y square equals to. Now we are just calculating the first quadrant area. So that's why y equals to this. The value of y in the first quadrant is positive. So that's why we write this. Otherwise, we will write if it's in the lower portion, then we have to add a negative sign here. So let's find the area. So it will be integration 0 to 4 y equals to root over 16 minus x square. That means integration will be x by 2 root over x square plus a square. Here a square value is 16 by 2 sine inverse x by a here is 4, right? So this is the value of integration part. So let's put the limit. So 4 by 2 root over 16 minus 16. This part will be 0. Here we get at 8 sine inverse. It's 4 by 4, right? So 4 by 4. So we will get 1 here minus 0 by 2. That means this portion will be 0. Okay, after that we will get 8 sine inverse 0, right? So the value will be, it's also 0 and this will be 8 into pi by 2 minus sine 0, 0. So 0, so we will get 4 pi. Okay. So squaring it. Try to solve this problem in another method. So let's try. Okay. Now see this problem as this. If we assume, if we take in this way and this, if we rotate this picture in this way, okay. So this is y equals to 0 here, and here y equals to 4, right? And the proof we have done in the starting of the class for the y equals to f of x, right? Similarly, we can prove this for x equals to f of y also, right? So for this case, what will be the value of the area? It will be integration a to b if we write here dy. So we have to write this or this maybe it's dy. Okay. So let's try to solve using this concept. So for the proof, we have to divide this line segment in this way, and we can easily prove in a similar way, right? So then what will be the area? Let's try this form. So putting the limit of y, so y equals to 0 from y equals to 4 and x dy. So what is the value of x? We have to write this equation of circle into this form, right? So similarly, the portion is in the first quadrant. So that's why x is positive here. So we will take only the positive value of x. So this this will be. So now we can solve this and easily getting the same result as you solved before. Quite easy. Understood? Now you can solve, you can find area under any curve, okay? Any continuous curve. So what we have learned in this class, we first in the starting of the class we proved the formula how we can find the area under a continuous monotonically increasing curve and using definite integral. After that we solve some problem and then we discuss the proof, how we can prove the same thing for monotonically decreasing function and the general cases. So in the next class we will learn how we can find the area if two curves are intersect each other like this, right? This type of problem. Okay. So thank you for your attention. Let's see you in the next class. Thank you.